One lesson 11, page 11, working on the bottom of the page with the trapezoid ABCF that's given. We're going to make some notations. We're going to change some of the lettering around because I noticed a typo. But as we advance forward, go ahead and maybe skip, as I skip pictures too, to the next image, the next image, and the next image. So the first thing that I did, starting from the given, is I looked at AB and CD, and I made a spike in the AB line and in the CD line. I think if I click, and if I click, you'll see them. Then I also drew double spikes on line segment BC and line segment AF because both of those are given to us that they're the same. And so ignore this lettering right here, BAD. I'm gonna fix it in a minute when I get there, and I'll tell you why. But I definitely am gonna identify angle AFD. So that's from angle A to angle F to angle D, and I put a little curvy arc line right there. And so I'm adding detail or information into the diagram that I plan on using or will have to be asked to use in a little bit. Also for number 3, I noticed that I wrote BAD. Just ignore that. I don't really use that. Okay. Figure ABCF. So right off the bat, there's a typo. ABCF is a parallelogram. That's not what I'm trying to focus on because that's what I'm actually trying to prove. So I needed to make a correction. ABCF is a trapezoid, and that's just given by the diagram. So after that, got a couple of lines right here. The fact is, if I have several given statements, and if one of my reasons is given, then number 2 has to be a list of my given statements. It doesn't. It also continues on to statement 3, angle AFD. And here's where I finally understood which was correct. Angle AFD is congruent to angle ADF. And I had to say that, and I had to make the adjustment in the given prompt. But I'm trying to eventually lead to getting an isosceles triangle. If you look at how angle AFD and angle ADF are the same, that makes a little isosceles triangle right over here. And so we need to use the fact that we have an isosceles triangle to further prove that something in the theorem. All right, so I'm kind of inserting, there's a row here that I may go back and add for future reference, but there's a row between 3 and 4 that needs to be added that says that triangle ADF is isosceles. And why? Well, it's because of the definition. I abbreviate definition DEFN, but triangle ADF is isosceles because of the definition of isosceles triangles where there are 2 congruent base angles, angle AFD and angle ADF. So that means the sides of the isosceles triangle are the same. That means AF and AD are the same. And then I have a statement that's typed up for you. It's called converse of isosceles triangle theorem. That's the fancy way of saying the triangles are the same, or the 2 sides are the same. Segment AD and BC are the same. That's what we just discovered because of the isosceles triangle. So therefore, because we have 2 pairs of sides that are equal, AD and BC, and DC and AB, that makes the figure ABCD a parallelogram.